Hi students, welcome to Preliminary Chemistry and the Chemical Earth video series. In this one we're going to have just a quick look, bit of an overview of decomposition reactions. So in the previous video we were having a bit of a look at the difference between chemical and physical changes, and in this one we want to focus a little bit more on one of those types of chemical changes, the change of decomposition. Now, the decomposition reactions are just where complex substances are broken down into simpler substances. Often this is a good example is where a compound is broken down into its constituent elements. There are various sources of energy that are required for decomposition reactions, and they can include heat, light, and electricity. Each of these a very important source of energy in order to facilitate decomposition reactions. Now, because decomposition reactions are chemical changes, they require a lot more energy, and therefore different sources of energy are needed for different types of decomposition reactions. We're going to have a look at some examples of each of these three types. In any chemical reaction, heat may be absorbed or released, and we have terms that are used to describe those reactions: endothermic reactions when the heat goes in, and exothermic reactions when the heat comes out. In these types of decomposition reactions, energy is required to kick off each of these processes, and we'll have a look at these examples next. So this is one that you would be familiar with, having recently completed a practical task in which you were actually doing a thermal decomposition. If we take copper carbonate and we heat it, so we use a heat energy source, then what we can do is we can break the copper carbonate into two simpler substances, copper oxide and carbon dioxide. You'll remember that the copper oxide is actually a black substance, a black powder, so that color change is a very important indicator of a chemical change, where we go from our sort of an aqua green kind of color to black. That color change tells us that a new substance has been formed. We also had gas being evolved as a consequence of this decomposition reaction. We tested this one with lime water, which is calcium hydroxide, and the precipitation of calcium carbonate causes that to turn a milky white color. There are a number of different examples of thermal decomposition reactions. Smelting is another one. It's often used with the addition of heat into say a metallic sulfide or a metallic oxide. Sometimes the presence of carbon can help to draw out the oxygen and reduce the compound back to its constituent metal. Electrical decomposition is the second type of decomposition, and this is something that you may have seen used in a voltameter, which is used to decompose water into its constituent elements with electrical energy. So you can see here's the equation for water, the breakdown of water into hydrogen gas, which we can test using a pop test, and oxygen gas, which we can test using the glowing splint test. And these are three important tests, this along with the lime water test for the presence of carbon dioxide, three important tests to identify the presence of three colorless gases. None of them have any particularly detectable odor, and so therefore if we see colorless, odorless gases, we need to be able to carry out tests to identify those gases, and obviously in this case water is going to be composed of hydrogen and oxygen, and should also be in a ratio of 2 to 1. So when we carry out this experiment, should see that difference of that ratio of 2 to 1 hydrogen to oxygen. Lightning can also, this is obviously a very, very high source of electrical energy, and it too can be used to decompose compounds in the atmosphere. And finally, ultraviolet decomposition or light decomposition. So light energy is also used to decompose different substances, and we'll have a look at this in class as well. So many of the silver halides, so things like silver chloride, silver iodide, silver bromide, can be produced as a precipitate from a reaction between silver nitrate and any of those halide salt solutions. And what this does is it produces a precipitate of silver bromide. Often the silver bromide can precipitate out, so it can also be as a solid form, but we may see some small amounts of that remaining in the solution as the precipitate forms. When that's exposed to ultraviolet radiation or light energy, the silver bromide can then decompose into silver and bromine. And these two elements together make up silver bromide. And so this again is an example of a decomposition reaction where the compound is being split up into its constituent elements. The same sort of thing can happen when ultraviolet light strikes ozone molecules. The difference between this and silver bromide, for example, is ozone is just a form of oxygen, the element oxygen, rather than decomposing a compound. But it will often decompose into oxygen molecules, perhaps even into additional oxygen atoms, which of course are very reactive, don't like to exist on their own, and will look for other atoms or molecules to combine. So these are three different types of decomposition reactions using heat, electrical energy, and light. Thanks for watching.